Straight to the point, no faking. Cooking MCs like a pound of bacon. Pause and copy this theorem, please. I apologize. It's tedious. I know. Okay, so what I want to do here to optimize engagement here, I want you to try to prove this. Not the full thing, but try it for a 2x2. At least contemplate why this may be true for a 2x2, please. Okay, let me zoom out here and so I can keep that theorem in front of us while I try to prove this. Okay, 1. If I have a row or column of zeros, so that would be, A, B, C, D. I'll take the second row to be 0 just to illustrate. A, B, 0, 0. Okay, if I write, you see how I got brackets over here, and these are straight lines. So what I'm indicating with the straight lines is that this is the determinant of the matrix inside. Anywho, if the second row is 0, then if I do my formula, I get A times 0 minus B times 0, which is, of course, 0, as expected. 2. So if I interchange two rows, so if I look at not A, B, C, D up here, but let's switch, well, whatever, switch the columns. I'll go B, D, A, C. What happens there? Well, I get B, C minus A, D, but this is the negative of AD minus BC, which is the negative of the determinant of A. So far, so good. 3. If you multiply, let's say, the second column by U, so I'll go UB, UD, what happens? Well, you get UAD minus UBC, and the U factors out, and behold, we have U times the determinant of A, which is what we were hoping for there. 4. If you have two distinct rows, so if you have like AB, AB, what's going to happen? Well, in general, you're going to do, I think the best thing to do would be to do a row operation. Never mind. Is just to cancel that. Let's just grind this out directly. I get AB minus, AB minus AB, which is 0. 5. If a multiple of one row of A is added to a different row. Now I call this, with some frequency, I call this a replacement. I call this a replacement operation. Okay, replacement operations are very useful in this chapter. Because, well, you can see it in number 5 here, okay? If I do a replacement operation, then the determinant does not change. Beautiful. Wonderful. No change. Simple as can be. So let's see how this works in the 2x2 case. So if I start with A is A, B, C, D, and then I do a row operation. So I'll go A and B here. I'll go row 2 minus 2, row 1. So it'll give me C minus 2A, D minus 2B. So if I work this determinant out, I am expecting it to be determinant of A. Let's see how that works. So I do my usual determinant formula for a 2 by 2. So I go this times this minus this times this. And we're going to see that the extra junk cancels out. So this thing with the twos, they cancel. And I get AD minus BC, giving me determinant of A. Okay, I cannot emphasize enough, this number 5 is especially useful. So we'll be using this left, right, and center. All right, so I've proven this for a 2 by 2, but this is actually true for an n by n. Okay, it's not so obvious, of course, but hopefully you have reason to believe that now.